He argues that the telescope provided results that could be refuted by naked eye observations, and that at the time there was no way of determining which of the telescope's findings were correct and which incorrect. He notes also that the telescopes of that time would have been very different from those currently used. Having no training in astronomy nor access to the original writings of Galileo, I turned instead to an online resource, the Galileo Project, and at the following page identified a statement suggesting that Galileo had observed that shadows were differentially cast across the lunar landscape according to the lunar cycle, and that he had intended to return to describe the lunar landscape more comprehensively. Nevertheless, he had apparently not done so. It is not unreasonable to suppose that if he intended to return to this area, that he considered the original sketches insufficient. In any case, Feyerabend seems to sidestep the critical point of Galileo's observations, which challenged the model in which all objects orbited the Earth. Thus again, returning to the Galileo Project at the following page, there are a number of significant events that precede the trials. 1604 to 1605, he witnesses a supernova explosion and concludes that there is a change in the heavens. 1609, Kepler publishes his first two laws of planetary motion. In 1610, his observations lead him to conclude that Jupiter has 3 orbiting satellites. In addition to all of this, Galileo was lecturing in mathematics, including lectures on motion, lectures on astronomy. He advances a theory about gravity, experiments on the relationship between tension and pitch in a string, invents a pump for raising water, builds scientific instruments, experiments with the pendulum, invents the thermoscope, and produces a work on hydrostatics. Assuming that all of the above is accurate, then it is reasonable to draw a number of conclusions. 1. Galileo had demonstrated both a depth of knowledge and breadth of knowledge in closely related areas to planetary motion. 2. The witnessing of a supernova explosion did not require a telescope, but challenged the notion of a constant heaven. 3. Kepler had already published his first 2 laws of planetary motion. 4. Galileo had closely observed the motion of satellites around Jupiter. In addition to this, I would argue that on the basis of the above achievements, it is entirely likely that Galileo utilized a combination of a vast body of accumulated knowledge in mathematics, contemporary physics, and experimental science in combination with hard work in order to arrive at his conclusions. I infer hard work on the basis of the considerable list of achievements that were attained in numerous areas. The emphasis on hours of study for attaining extraordinary achievements has been discussed at some length in a work by Malcolm Gladwell titled Outliers. Thus I would speculate that the combination of long hours of study and accumulated knowledge has resulted in a significant intuition in the relevant area, and this intuition might not have been easy for Galileo to formulate explicitly. Additionally, bringing forth all of the relevant material at the time may have been sensitive. It is difficult to know Galileo's reasoning, or indeed the events, on the basis of Feyerabend's discussion of a translation of a text that is nearly 400 years old. In chapter 10, Feyerabend writes that Copernican theory and astronomy were in trouble because of refutations, and it survived because...
But that being in harmony with still further inadequate theories, it gained strength, and was retained, the refutations being made ineffective by ad hoc hypotheses and clever techniques of persuasion.
While he quotes from others in order to support his argument, I would suggest the following. Assuming that in the above quote he is referring to selected observations of the telescope being used to support Copernican theory, I would challenge both parts of this. Firstly, although Copernican theory might have been in trouble, every theory can be challenged by those who are so interested to do so. It is therefore not unusual that a theory, and a successful one at that, would have its critics, and whether it is considered to be in trouble or not is a matter for judgment. On the second point, we know in retrospect that the telescope is a successful technology, and observations made with the telescope have provided many important scientific discoveries. At the time, he argues that it did provide some observations in support of the Copernican theory, and it is reasonable to assume that he selected those observations which fitted with the theory, what we might refer to now as confirmation bias. He then argues that other techniques such as persuasion were used to support the argument. Even when the supporting data set is watertight, however, persuasion is an important skill and represents the way that not just science, but any activity with a social aspect is performed. I would thus classify this as a distinction between the process of doing science and communicating science. Chapter 11. In Chapter 11, Feyerabend argues that a new theory will have little empirical evidence. Therefore, there will be a move away from a dominant theory with abundant empirical evidence to one with very little. During this period, an alternative with little empirical support would need to be supported with alternative means, predominantly tools of persuasion.
I suggest that what Galileo did was to let refuted theories support each other, that he built in this way a new worldview which was only loosely, if at all, connected with the preceding cosmology, everyday experience included, that he established fake connections, and that whenever possible he replaced old facts by a new type of experience which he simply invented for the purpose of supporting Copernicus.
While he is more complimentary of Galileo a little later and indeed praises his techniques of effective communication, I would question the above. Firstly, as already argued above, I don't think it is reasonable to say that he was dealing with refuted theories, for the reasons given above. Secondly, I would argue that the evidence has not been adequately presented to support the assertion that he has, quote, established fake connections, unquote, or that he, quote, invented, unquote, experience to support Copernicus. More than likely, his prolonged periods of observation with the telescope would help him to develop an intuition for his observations, allowing him to discount those findings which resulted from aberrations in the telescope technology that he was using. This is speculation, but so also, in my opinion, are the above remarks by Feyerabend. Feyerabend does have some suggestions which I would say are reasonable. Thus he argues that the dominant scientific theories of the time occur in a historical context where there are implicit assumptions and social factors that modify the way in which the theory is perceived and used. However, here again these are generalizations without the supporting evidence base. The remaining arguments are covered in the response to Chapter 9. Chapter 12 is brief, and Feyerabend essentially argues that the same approaches discussed previously can be used, quote, in other fields as well, unquote. At this point he refers to the mind-body problem, but does not discuss it any further. In this chapter, Feyerabend looks at the two trials of Galileo by the Church. He argues that Galileo didn't have sufficient evidence to support his defence of Copernicus at that time, that the scientific, or as it was then referred to, philosophical evidence was considered insufficient. However, Feyerabend does not delve further into why this evidence was considered insufficient. Curiously, Feyerabend writes about one trial that
it had no special features except perhaps that Galileo was treated rather mildly, despite his lies and attempts at deception.
Such a strong statement is not qualified except by a rather curious footnote which reads, quote, "The reaction of an admirer is characteristic. This absurd pretense," unquote, which I do not think justifies the above. He goes on to repeat the previous assertions.